Betelgeuse, also known as a red giant star, would extend out to the orbit of Jupiter if placed where the Sun is. It's enormous and very unstable, about to explode. Renowned scientist Brian Cox has issued a very serious warning, prompting the question, are we about to witness a supernova explosion that will change the night sky forever? Let's dive in. In the vastness of the universe, stars are born, live, and die in amazing ways. Recently, one star has caught the attention and concern of astronomers and the general public, Betelgeuse, a red supergiant star in the constellation Orion. It is incredibly massive and ancient, with a unique reddish color and varying brightness that have long been intriguing. Recent events have heightened interest in this cosmic giant, indicating we may be on the verge of a monumental event in its history. What might these changes in Betelgeuse mean? Are we witnessing the beginning of a cosmic spectacle on an unimaginably huge scale? Betelgeuse is a stellar giant approximately 764 times larger than our Sun. Its size is almost beyond human comprehension. If it replaced our Sun, its surface would extend beyond Mars's orbit, enveloping Mercury, Venus, Earth, and Mars. This colossal size not only illustrates the physical grandeur of Betelgeuse, but also indicates its stage in the stellar life cycle as a red supergiant. Betelgeuse is nearing the end of its life, expanding and cooling after exhausting the hydrogen in its core and fusing helium. The star is estimated to be between 8 and 8.5 million years old. While relatively young in human terms, it is ancient in stellar terms. Over millions of years, Betelgeuse has undergone dramatic transformations, evolving from a hot blue star to the red giant we observe today. It is now in its final stage as a red supergiant, changing throughout its life due to the ongoing pressures of nuclear fusion and gravity. Betelgeuse's unique reddish color arises from its cooler surface temperature compared to other stars, like our Sun. The Sun's surface is around 5,500 Kelvin, while Betelgeuse's surface is about 3,500 Kelvin. This cooler temperature allows Betelgeuse to emit light at wavelengths that make it appear red, revealing information about the star's physical state and the processes occurring within its vast gaseous volume. Historical records from Roman and Chinese eras indicate that Betelgeuse was yellow around 2,000 years ago. By the 9th century, Arabic astronomers noted its red color, signifying the star's evolution over time. Another intriguing aspect of Betelgeuse is its changing brightness. As a semi-regular variable star, its brightness fluctuates periodically, captivating scientists and stargazers for centuries. Typically, Betelgeuse goes through a 400-day cycle and a longer 5-year cycle. Sir John Herschel documented these cycles as early as 1836, and Aboriginal folk histories may date back even further. However, what truly makes Betelgeuse mysterious is not just its brightness changes, but their irregularity. Unlike many stars that vary in brightness predictably, Betelgeuse sometimes deviates from this pattern, suggesting complex and less understood processes within its immense form. Recently, astronomers and stargazers worldwide were shocked to observe a dramatic and unexpected change in Betelgeuse's appearance, known as the Great Dimming. In late 2019, Betelgeuse began to dim mysteriously, losing its light at a rapid rate. By February 2020, it was at its dimmest. Betelgeuse, usually visible to the naked eye even in areas with significant light pollution, became much fainter. This unprecedented dimming raised numerous questions and concerns. Monitoring Betelgeuse's activities is complicated by the time paradox. Light from Betelgeuse takes almost 700 years to reach us, as it is about 725 light-years away. This time lag makes predicting and monitoring rapid changes in its behavior challenging. The Great Dimming event highlighted the difficulties of real-time sky observation and our limited understanding of the vast and mysterious realms of space and time they inhabit. Andrea Dupree, deputy director of the Center for Astrophysics at Harvard and Smithsonian, and her team closely monitored Betelgeuse's celestial drama. They used the Hubble Space Telescope to observe the massive star as part of a 3-year study to track changes in its outer atmosphere. These observations provided new insights into how a variable star like Betelgeuse operates. Researchers examined the layers above Betelgeuse's surface, heated partially by the star's swirling convection cells, thanks to Hubble's sensitivity to ultraviolet light. Further analysis of Hubble spectra taken at different times in 2019 and 2020 revealed the movement speeds in Betelgeuse's upper atmosphere. The study showed that material was moving from Betelgeuse's surface into its atmosphere at about 200,000 miles per hour. This hot, dense material eventually formed a dust cloud that dimmed the star during the 3 months of the outburst. Dupree and her team estimated that about twice as much material as usual was ejected from Betelgeuse's southern hemisphere. While all stars lose mass over time, Betelgeuse's mass loss was particularly notable because it occurred at a much faster rate than the Sun's. Astronomers debated whether this event could signal an impending supernova explosion, given the magnitude of the mass release and the subsequent dimming. Being only about 725 light-years from Earth, Betelgeuse adds to the intrigue, as any such explosion would be visible from Earth and offer a rare opportunity to observe a supernova up close. But the question remains, what does this dimming mean for Betelgeuse's future? Is it a sign of an imminent supernova, or is it merely a one-time event in the star's long and complex life? Several theories have been proposed to explain this rapid change. One popular theory suggested it was a precursor stage in the supernova explosion process, gaining traction due to the belief that Betelgeuse is nearing the end of its life. Another common theory posited that dust, possibly from the star itself, was obstructing our view. It is known that Betelgeuse and other red supergiants shed material, which could accumulate into a dust cloud thick enough to obscure the star's light. A third theory examined how changes in the star's photosphere, the visible outer layer, might affect its apparent brightness. Spectroscopic studies indicated that Betelgeuse's effective temperature dropped, suggesting that the star may be dimming due to a large dark spot on its surface. The fact that Betelgeuse's temperature dropped by at least 170 Kelvin around the time of the dimming supported this idea. In the end, the Hubble Space Telescope helped us understand what was happening with this unusual event. Hubble's observations showed that the dimming of Betelgeuse was likely due to a large amount of hot matter being ejected into space, forming a dust cloud that obscured part of the star's surface. This dust cloud was believed to consist of very hot plasma that erupted from a large convection cell on the star's surface. As this plasma moved through Betelgeuse's hot atmosphere to cooler outer layers, it formed dust grains that created a cloud blocking light from about a quarter of the star's surface. Hubble's ultraviolet light spectroscopic studies, which began in January 2019, were crucial in piecing together the events leading up to Betelgeuse's dimming. These studies detected dense, hot matter moving through the star's atmosphere in the months before the dimming. Several ground-based telescopes also observed the star's brightness decrease in December 2019, particularly in its southern half. Initially, the ejected material was brighter than the star itself, but as it moved outward and cooled, it turned into a dark cloud. This outflowing matter and the resulting dark cloud were believed to be responsible for the sudden dimming of the star. The explosion was immense, putting Betelgeuse at the center of astronomical attention. The star expelled about 400 billion times the mass typically ejected in a normal coronal mass ejection. This material, thought to be several times the mass of the Moon, was significant for both Betelgeuse and our understanding of stellar processes. What does such a massive ejection mean for theories about Betelgeuse and supernovas in general? It has profound implications. Red supergiants, like Betelgeuse, are thought to lose mass at a fairly steady rate before they explode at the end of their lives. However, the scale of this ejection challenges this idea, suggesting a more turbulent and possibly unpredictable end-of-life phase for these stars. Could Betelgeuse be preparing for its grand finale, a supernova explosion in a few thousand years? New studies speculate that such an event might happen sooner than previously thought, possibly within just a few decades. Another important aspect of the Betelgeuse puzzle is the concept of bow shock. This massive star hurtles through space at about 67,000 miles per hour relative to the surrounding interstellar material, creating a bow shock similar to the wave formed by a ship's bow moving through water. This effect occurs when the star's outer layers interact with the interstellar gases and dust. It is a striking example of how dynamic the star is and how it interacts with its surroundings. The bow shock not only reveals Betelgeuse's current state, but also provides insights into stellar evolution and mass loss. What about the star's recent behavior? Observations indicate that after the material ejection, Betelgeuse's surface cooled and became less dense, suggesting that the star remains unstable years later. Hydrodynamic models link the star's convective activities, the mass ejection, and the subsequent change in pulsation mode. This ongoing instability raises questions about the internal processes at play and how they might culminate in the star's ultimate fate. While Betelgeuse will likely continue to shine brightly in the night sky for the foreseeable future, its recent outburst of activity serves as a reminder of the dynamic and often unpredictable nature of our universe. For scientists, it underscores the importance of continuous observation and study, providing a wealth of data that may eventually help us understand these titanic stellar phenomena. The uncertainty surrounding Betelgeuse highlights the need for further study and continuous monitoring. While a supernova explosion would be a breathtaking sight and a unique scientific opportunity, it would also be a rare event. If it were to occur, it would light up the night sky, making Betelgeuse visible even during the day for several weeks or months. Such an explosion would provide invaluable data on the life cycles of stars and the mechanisms behind supernovae. The recent changes in Betelgeuse underscore the dynamic nature of our universe and the importance of scientific inquiry in understanding it. Whether or not Betelgeuse will explode in our lifetime, its behavior continues to captivate and intrigue scientists and stargazers alike.